Okay, for homework 914, if you do this work, it will give you the green light to come in and make up yesterday's quiz for 914. So write down this work, write down the words. Again, we'll give you the green light. So me showing you how to do those problems there. First one, 139. Know that this is geometric. Know that these are timesing by 3. I could use that in the geometric pattern to fill in that table. Just take that 9 times 3 gives me 27. 27 times 3 gives me 81. 81 times 3 gives me 243. That number times 3 gives me 729. Know that when you're going up the table to the -1 term, -2, and -3, you're doing the opposite of timesing by third. You're dividing, or you're timesing by 1/3. And the number that you're timesing by 1/3 is this 1. 1 times 1/3 will give me that next term right there, which is 1/3. 1/3 times another 1/3 will give you 1/9. That 1/9 times another third gives me 1/27. If I was to change those numbers to decimals, this is 0.3 repeating 1 divided by 3. If I do 1 divided by 9, my calculator works. That gives me 0.1 repeating, so getting smaller. And if I do 1 divided by 27, that gives me 0.03. So you can see when x is -1, y is a 1/3 or 0.3. When x is -2, y is 1/9 or 0.1. When x is -3, y is 1/27 or 0.03. That's where I'm getting those values. 1 divided by 3, 0.333. 1 divided by 9, 0.1 repeating. 1 divided by 27. I want you to write the recursive form. I didn't have you use it for this. I just want you to see that for this one. You're timesing by 3. First word is contest. Contest. All right, that's recursive. Explicit, here we go. Here's the first one. You could either use that first term right there or the 0 term, that 1 times the common ratio number raised to the x power, or I could use and shift over and not use that 1, but shift down the column and use this 3 instead. I could use 3 times 3, but this would be to the x minus 1 power. If I'm having you plug in 10, you're plugging in 10 into both of those to show me that you get the same answer. So here we go. Plugging that in to the first one. Plugging in 10. 1 times 3 to the 10th. Use your calculator to times 3 times itself 10 times, or my calculator quickly spits out 59,049. So at the 10th term, it jumps way up to 59,049. Make sure you put that number best you can right here. 59,049. Try to get that number in there. Know that if I do the other form, it will give me the same answer. This one right here is me using this form right here. Now I'm going to use the bottom one. I'm going to use this guy right here. So here I go. If I do that and plug that in, that will be f of, do this in black, 10 comes from 3 times 3 to the 10 minus 1 power. Gives me the function at the 10th term is 3. Leave that 3 alone. 3 to the 9th. Evaluate that. Gives me the 10th term comes from me multiplying 3 times that value that got spit out, 3 to the 9th, 19,683. And when I times that by 3, gives me the same answer. The 10th value, 59,049. All right, now you need to know how to graph these. So here we go. If I graph these coordinates, remember these are all coordinates. The first one is -3 for x. I got 1/9, which is about 0.03. The second one, -2 for x, I got 1/9, which is about 0.1. The third point, -1, I got for that one 1/3, which is about 0.3. And then I have the 0, 0, 1. And then I have 1, 3. And then 2, 9. Most people can graph the nice, neat whole number ones, these guys. So if you do that, 0 for x, 1 for y. 1 for x, 3 for y. 2 for x, 9 for y. But now the small ones. -1 for x, going up 0.3, not very high. Going over 2 for x, going down a little bit lower. Going over 3, -3 for x, even lower. And you can see when I draw my line, that's why that part of the line is nice and flat, where this one just jumps up because those numbers start to skyrocket. You can see this 10th one is way up there at 59,000. Second word is ocean. Ocean. All right, second problem off the quiz, this one. I want you to see that this is arithmetic. These are adding by 3. I could use that to fill out the pattern. This is 14, 17, 20, but no way is that 23 because that's the 51st term. I could use that to backtrack a few. -3, bust out of the table here, go backwards. So 0 term, -1, -2, be able to go both ways. That 5, take away 3, gives me 2. So there's the 0 term. When I go back another step to -1, 2 minus 3 gives me -1. Back another step, -1 minus 3 gives me -4. For this one, the recursive, and to use it, this one is +3 because I'm adding. If I'm using it to find the 6th term, here we go. Plug in a 6 right there. Get the 6th term comes from me using the value of the 5th +3. Replace that value of the 5th, which really what it is on that table, 17. And then add that to 3 to support your work. Y, the function at the 6th term, is 20. Now I want you to use both forms of explicit. First one, I could either use that 3 number times x plus or minus the y-intercept term 2. Or, of course, I could shift over and use that 3, but x minus 1. And then don't use that 2 right there. Shift over to the 5, to the term next to it. Use that 5. Those are both forms of explicit, using the 0 term or the first term. I want you to plug in 51 into both to show me that that gives you the same answer. So if I plug in 51 right here, 3 times 51 plus 2 gives me 153 plus 2 gives me 155. Put that right here. If I plug in to the second one here, should give me the same answer. But for this one, remember you're plugging in 51 and having to subtract 1. And then after that, you're adding 5 to it, not adding 2. So this is 3 times 50. Gives me the function at the 51st term, 150 plus 5, or that same answer as the one above it. Now graphing it. I want to know that you people can graph. So some people like to write all the coordinates. That first coordinate, -2 for x, really -4 for y. -1, -1. Next one is 0, 2. My next point is 1, 5. My next point is 2, 8. If I graph them, they should be a nice, neat, straight line. So left 2, down 4 for y. -1 for x, down 1 for y. 0 for x, up 2 for y. 1 for x, up 5 for y. 2, up 8. Noticing as I draw my line, every point on that line has that same slope pattern of over 1, up 3, over 1, up 3. If you look at it, it touches the y-axis right there at the 0 term, which of course is 0, 2. That's the y-intercept. Again, know that straight line arithmetics, the slope matches the rate of change number, that 3. For geometrics, there is no constant slope. There's no slope number. There's no constant rate of change. All right, show all of this work, and I'll give you the green light to do a nice, easy makeup quiz. The third word is commitment. Commitment. Good luck.